Okay, starting section 9.4. We'll be spending a couple days here. Definitely an exercise in algebra here. 9.4, day 1. What we've got going on here are called the trig reduction formulas. We're going to develop the trig reduction formulas. For integrating. For integration. I'm going to do 3 of them with you. You've got 3 of them for homework tomorrow. So what we're going to do is do one numerical one and then one in the general end case. And what we want to have happen is in our answer, we still want an integral with a reduced power from what we started with. So what we're going to be doing is going through the integration by parts. We're going to do one iteration of it and simplify and then see we should be where we need to be. So here, we'll just get started. Say I had the integral of cosine to the 6th x dx. Okay, so when I break up my u and my dv, again, dv needs to be something that you can integrate. Well, the only power of cosine that you can integrate is cosine to the 1st. So I'm going to put a cosine to the 1st over here with the dx. That will leave me with cosine to the 5th here. Okay, one iteration. That means one derivative, one integral, and we're going to stop. So here, doing the power rule, remember this is like to the 5th power. So you've got an inside with an outside power, so the 5 comes down, times cosine to the 1 less power, times the derivative inside is a negative sign. So the negative sign. Okay, over here, integrating. Think about the integral symbol. What has cosine as its derivative is just sine. So now we've got multiply, integrate, positive, negative, integrate. So the integral of cosine to the 6th x dx equals cosine to the 5th times sine multiplying here and integrating. I have a negative times a negative. That's going to give me positive. Oh yeah. And then we've got 5. The integral, I'll put the 5 out in front. Integral of cosine to the 4th x, and then I'll have a sine squared x. Okay, what I want to end up with, I'm done when I end up with an integral that just has cosine to a reduced power from what I started. This has cosine and sine, so I'm not done. But what I can do is rewrite the sine squared and bring back in more cosines. So remember, using the Pythagorean identities, sine squared equals 1 minus cosine squared. So I'm going to leave everything else the same. Cosine to the 4th is going to stay. Rewriting sine squared as 1 minus cosine squared. And then breaking this apart into 2 separate integrals. So I'll have 5 times the integral of distributing cosine to the 4th x dx. And then 5 times the cosine to the 4th times the cosine squared. So that will give me a minus the integral of cosine to the 6th x, that was the 5, dx. Okay, so probably should have left that 5 on the inside so it was easier to see. 5. So it was 5 cosine to the 4th and then 5 cosine to the 6th. Now what I can do, this is my original, I can add 5 integrals of this back over here, and then that will leave me with just an integral of a reduced power, which is what I was looking for. So at this point, I'm going to add 5 integral of cosine to the 6th x dx. Add add 5 integral of cosine to the 6x dx. Recognize these as like terms. I've got one of these plus 5 more of these, giving me 6 integral cosine to the 6x dx equals, and at this point I want to write out everything that I have, so I'm back here at my beginning that I kind of just left hang up there. Cosine to the 5th x sine x, and then plus, because that canceled, 5 integral cosine to the 4th x dx. And the only thing I have left to do is get rid of my 6 by dividing everything by 6. Divide by 6. Divide by 6 gives me a 1/6 here, and then a 5/6 here. So, looking at this, I can kind of guess what the general case would be. If this was cosine to the nth, so my n is a 6 in this case, it appears that the integral of cosine to the nth power, its reduction formula is, because n was a 6, I've got a 1 over n, cosine, now I've got a 5. 5 is 1 less than 6, so my guess is n minus 1, x times sine x, plus, I've got a 5, that's 1 less than my nth power, so I'm going to say n minus 1, over n was 6, integral of cosine to the 4 is 2 less than my power, so my guess is n minus 2 x dx plus c. Okay, we're not actually going to use these reduction formulas until day 2. So for today, all we're doing is discovering these. Okay, and like I said, that was a guess on what I think the general case is with n in the power. Now I'm actually going to go through and redo this whole problem, carrying along the n to start with, and hopefully it looks like this when I'm all done. So let's try it again. So this is like example, well, I guess it is example 2. I was going to call it 1b or something, but okay. Integral of cosine to the nth x dx. Okay, we're just going to follow the plan we did in this first example with our u and dv. Okay, I have to let the dv be cosine to the first. So that's going to stay, cosine to the first. That means because I've used one of them up over there, I've got one less for here. So in terms of n, the u would be cosine to the n minus 1. Because there's 1 here, I've got 1 less over here, and I started with n of them, so that makes n minus 1. Okay, integrating. I have the same integral as I did before. The integral here is sine x. Here I'm going to do derivative with the power rule. I'm going to put that n minus 1 on the outside. So that power comes down, so it has to be in parentheses, times cosine to the 1 less power. If I've got n minus 1 and I subtract another one, I'm going to have n minus 2. And then the derivative inside is still negative sine x. Make sure I've got that right before I move on. There's nobody here to tell me if I made any little mistakes. Okay, so far so good. Okay, now we multiply, integrate, positive, negative. Okay, so starting at the beginning, cosine to the nth x dx equals this cross product, which will be a positive cosine to the n minus 1x times sine x. This will be plus the integral of, and when I multiply here, I have my n minus 1 cosine to the n minus 2, and then the sine times the sine is going to give me a sine squared. Okay, and if I look back, the next thing I did was get rid of the sine squared and introduce back in cosine by using the Pythagorean identity. So I'm going to ditto this. This is going to get rewritten here, so plus the integral of n minus 1 cosine to the n minus 2 x times, in place of sine squared, 1 minus cosine squared. Now I'll take this whole thing here and distribute it to the 1, and then distribute it to the cosine squared. So ditto that first term. Still have plus the integral of n minus 1 cosine to the n minus 2 x. That was all times 1. Now I'll have minus the integral of n minus 1 times, and adding exponents here, n minus 2 plus 2 is just n. Okay, now I can see, because this is a power of n, just n, it matches my original. So I can add n minus 1 integrals to the other side. So I'm going to add, and remember how many of them I have is this n minus 1, because that's a constant that can be out in front of the parentheses. Okay. So think of this as one of these again, plus n minus 1 of these. The ones cancel, I'm left with n. Integral of cosine to the n x dx equals, still have my first term, I'm ready to write that down. Cosine to the n minus 1 times sine, plus this integral of n minus 1 cosine to the n minus 2x dx. And then my last step to do is to divide by the n. So that will cancel that. This will give me 1 over n. This will give me n minus 1 over n. And if I look back at my guess, 1 over n cosine n minus 1 sine x plus integral n minus 1 over n. Here I had it outside, here it's inside, cosine of the n minus 2. Yeah, oh, forgot my plus c. Okay, there's your first reduction formula, cosine. Like I said, I'm going to do 1 or 2 more with you. You've got the other ones for homework tomorrow. So we'll do them the same way. We'll do a numerical one, then we'll do the general case. Number 3. I don't know if there's a trick in each one. I can't remember. See, the next one we're going to do is tangent. Tangent to the 10th x dx. Okay. Doing tangent. I didn't even do an integration by parts here. Oh, I know why. Okay, think about tangent. Gosh, can I still get that? I'm going to stop this for a second. I'm going to see if I can make this shorter here. I'm going to stop and hold on.